This is section 8.1 of geometry. We're going to talk about the Pythagorean theorem and its converse. So let's start with the Pythagorean theorem. And we're going to need a right triangle. Okay, I'm going to label my sides now. And the side that is opposite of the 90-degree angle is typically side C. And of course C is our hypotenuse. Then the legs, we can call them A and B. So the Pythagorean theorem states that if you have a right triangle, then there's a relationship that exists between the sides. The length of the hypotenuse squared is going to be equal to the sum of the squares of your legs. In other words, c squared equals a squared plus b squared. Now Pythagorean triples, those are going to be the set of whole numbers, and a whole number is a positive, non-decimal or non-fraction number. So we have the set of whole numbers that fit the Pythagorean theorem. For example, I could say that 3, 4, and 5 form a Pythagorean triple. And I could say this because 3 squared plus 4 squared is equal to 5 squared. 3 squared is 9, 4 squared is 16, and then 5 squared is 25. 9 plus 16 is 25. So they are equal. So there we go. 3, 4, and 5 form a Pythagorean triple. Okay, let's start by practicing problem 1a. Find the value of x. Give your answer in simplest radical form. We want to state whether the side lengths form a Pythagorean triple. So we're going to start by filling in the Pythagorean theorem. And that is going to be a squared plus b squared equals c squared. So let's start by identifying c. Now c is the longest side in your triangle. It's always going to be the side that's opposite of your 90-degree angle. So you start by finding your 90-degree angle and go opposite of that. That's going to be c. So I'm going to put x in for c. And then the 2 and the 6, those are going to go into a and b. So I have 2 squared plus 6 squared equals x squared. 2 squared is 4. 6 squared is 6 times 6. And 4 plus 36 is 40. Alright, so at this point to solve for x, you're going to have to take the square root of both sides. So I get this x over here. 40 is not a perfect square, but it has factors that are. So we're going to see if we can break 40 down. 1 and 40, 2 and 20, 4 and 10, 5 and 8. I think those are all the factors. Now go through your list and circle the largest perfect square, or any perfect squares. And you'll see that you only have one pair. We're going to need to use the numbers 4 and 10 to replace 40. Okay, so I'm running out of room. I'm going to continue this right over here. So I have x is equal to the square root of 4 times 10. Well, what's the square root of 4? We know that is 2. So we're going to write 2. And then I look to take the square root of 10, which cannot be simplified, so 10 stays underneath the radical, which means the length of my hypotenuse is going to be 2 square root of 10. And I'm done. There is one more thing that we forgot to do here. The last part of the question says, state whether the side lengths form a Pythagorean triple. Ours do not, because x was a decimal. If there's a radical in your answer, that means you have a decimal answer. So this is not a Pythagorean triple. Okay, let's move on to practice 1b. Same directions. We're going to go ahead and solve for the unknown length and then see if we have a Pythagorean triple. My unknown length, well, let me back up. Let's start by finding c. Because I have a squared plus b squared equals c squared. And I always want to start by identifying my hypotenuse. There's my 90-degree angle, so I want the side opposite of that. So I'm going to put 12 in for c. And then this could be a. It could be b too. And I'm going to leave the other one then as b squared. If you want to mark it x, that's perfectly fine. So 4 squared is 16. We're going to leave b squared alone. 12 squared is 144. So, alright, so let's subtract 16 from both sides. And we get b squared equals 128. Now I need to take the square root of both sides. And I'm going to continue this over here. I have b equals the square root of 128. Is 128 a perfect square? No. So you need to find factors of 128. And hopefully you'll find a pair in which one of the factors is. Let's see, we have 2 and 64. And I'm going to go ahead and stop there because 64, that's going to be my largest perfect square. 4 would work also, but 64 is going to be larger. So what I'm going to do then is rewrite b to be the square root of 64 times 2. So the square root of 64 is 8, and the square root of 2, I cannot simplify that, so it's going to stay underneath the radical. So I have b is equal to 8 times the square root of 2. Alright, this though, well, the question is, does it form a Pythagorean triple? You have a side that measures 4, one side that measures 12, and the other side that would be a decimal, so no, not a triple. And I'm just going to call p triple. Alright, for 1c, I want you to complete this problem on your own. Come with it finished to class, please. Alright, last practice problem, number 2. Randy is building a rectangular picture frame. He wants the ratio of the lengths to the width to be 3:1, and the diagonal to be 12 centimeters. How wide should the frame be? And then we want to round our answer to the nearest tenth of a centimeter. Alright, so on a problem like this, first thing I want you to do is start by drawing a picture. Here's my frame. I have a length, a width, and then I need a diagonal. And it said the diagonal needs to be 12 centimeters. And if I have a rectangle, then I'm going to have a 90-degree angle. Now this part, the ratio of the lengths to the width is 3:1. That tells me that the length needs to be 3 times larger than the width. So let's say the width is W. Then the length needs to be 3 times that width. Okay, well, how can we solve for the width? If you're thinking Pythagorean theorem, you are correct. We have a squared plus b squared equals c squared. So then let's start by substituting. The 12 is my c, and then the legs, they can be whatever. I'm going to call this one a, and w, I'm going to call it b. Or it's going to go in the b spot. So I have 3w squared, and you have to put parentheses around that, plus w squared is equal to 12 squared. Alright, so if you have 3w, the quantity squared, that's really like you have 3w times 3w. Just means you have 2 of those. So you end up with 9. 3 times 3 is 9. And w times w is w squared. So I have 9w squared plus 1w squared. And 12 squared is 144. I can go ahead and combine these like terms. 9w squared plus 1w squared, we get 10w squared. Alright, go ahead and solve the rest for w. You have, I think, 2 steps left and then you're done. And we'll talk about the rest of this problem tomorrow. Good luck!